Cool. Let's reload that. Move my stream on the right. And they're ready to rumble. Alright, so welcome back. Chill one today. I'm gonna just gonna do a little bit of this. We left off making the generate AST from the whatever it's called again. Whatever the lock subrepertoire thing tells me. I'm gonna try to finish it off hopefully by the end of this stream. It's really late, so maybe we won't do too long. But yeah, let's do it. So I think we got up to, let's see, we'll define type. We finished that one, we right print that, yeah. Just working with truths. Okay, put your imagination. Actually, I have to zoom in because I'm kind of blind, I'm not gonna lie. Especially because it's late at night. Right, put your imagination hat on for a moment. Even though we aren't there yet, consider what the interpreter will do with the syntax trees. Each kind of expression locks behaves differently at runtime. This means the interpreter needs to select a different chunk of code to handle each expression type. With tokens, we can simply switch on the token type, but we don't have a type enum for the syntax trees. Just a separate Java class for each one. We could write a long chain of types like this, but all of those sequential type tests are slow. Expression types whose names are alphabetically later would take longer to execute because they didn't fall through more if cases before finding the right type. That's not my idea of an elegant solution. We have a family of classes and we need to associate a chunk of behavior with each one. The natural solution in object-oriented languages like Java is to put the behaviors into methods on classes themselves. We can add an abstract interpret method on expert, which each subclass then would implement to itself. Hold on, I need some gum because I'm pressed. Oh, what? Where is it? I literally bought a pack of gum earlier. What? Alright, I'm gonna have to run. I'll be right back. Okay. Wait. Alright, so I hope my chewing isn't loud. Oh, it picks it up. Oopsies. Alright, this works alright for tiny projects, but it scales poorly. Like I hinted before, these tree classes span a few domains. At the very least, both the parser and interpreter will mess with them. As you'll see later, we need to do name resolution on them. If our language was statically typed, we'd have a type checking patterns. If we added instance methods to the expressions classes for every one of those operations, that will smush a bunch of different domains together. That violates separation of concerns and leads to hard to maintain code. Okay. This problem is more fundamental than it seems at first. We have a handful of types and a handful of high-level operations like interpret. For each pair type and operation, we need a specific implementation. Picture a table. Okay. Rows are types and columns are operations. Each cell represents the unique piece of code to implement that operation. Oh no. An object-oriented language like Java assumes that all the code in one row naturally hangs together. It figures all the things that you do with a type are likely related to each other, and the language makes it easy to define them together as methods inside of a same class. This makes it easy to extend the table by adding new rows. Simply define a new class. No existing code has to be touched, but imagine if you wanted to add a new operation, a new column. In Java, this means cracking open each of those existing classes and adding a method to it. Functional paradigm, languages in ML family flip that around. There you don't have classes with methods. Types and functions are totally distinct. To implement an operation for a number of different types, you use to define a single function. In the body of that function, use pattern matching, sort of type-based switch on steroids. To implement the operation for each type all in one place. This makes it trivial to add a new operation. Simply define another function that pattern matches all of the types. But conversely, adding a new type is hard. You have to go back and add a new case to all the pattern matches in all the existing functions. Each style has a certain grain to it. That's why the name literally says an object-oriented language wants you to orient your code along the rows of types. A functional language instead encourages you to lump each column's worth of code together into a function. A bunch of smart language nerds noticed that neither style made it easy to add both rows and columns to the table. They called this difficulty the expression problem, because, like we are now, they first ran into when they were trying to figure out the best way to model expression syntax tree nodes in a compiler. People have thrown all sorts of programming language features, design patterns, and programming tricks to try and knock that problem down, but no perfect language has finished it off yet. In the meantime, the best thing you can do is try to pick a language for those orientation matches and natural architectural seams in the program we're writing. Object orientation works fine for many parts of our interpreter, but the tree classes rub against the grain of Java. Fortunately, there's a design pattern we can bring to bear on it: the visitor pattern. The visitor pattern is most widely misunderstood is the most widely misunderstood pattern in all of design patterns, which is really saying something when you look at the software architecture excesses of the past couple of decades. The trouble starts with terminology. The pattern isn't about visiting and the accept method, and it doesn't conjure up anything helpful image. It doesn't conjure up any helpful imagery either. Many think the pattern has to do with traversing trees, which isn't the case at all. We are going to use it on a set of classes that are tree-like, but that's a coincidence. As you see, the pattern works well as a single object. The visitor pattern is really about approximating the functional style within an OOP language. It lets us add new columns to that table easily. We can define all of the behavior for a new operation on a set of types in one place without having to touch the types themselves. It doesn't mean that the same way we solve almost every problem in computer science, by adding a layer of indirection. Before we apply it to our auto-generated expert classes, let's walk through a simpler example. Say we have two kinds of pastries. Nice. You want to be able to define a new pastry operation, cooking them, eating them, decorating them, without having to add a new method to each class every time. Here's how we do it. First, we define a separate interface. Each operation that can be performed on the pastries is a new class that implements that interface. Each operation that can be performed on pastries is a new class that implements the interface. Okay. It has a concrete method for each type of pastry that keeps the code for the operations on both types all nested snugly together in one class. Given some pastry, how do we route it to the correct method on the visitor based on its type? Polymorphism to the rescue. We add the method to pastry. Which gives us access to all of them. To perform an operation on the pastry, we call its accept method and pass in the visitor on the operation we want to execute. The pastry, the specific subclasses override the implementation of accept, turns around and calls the appropriate visit method on the visitor and passes itself into it. That's the heart of the trick there. It lets us use polymorphism dispatch on the pastry class to select an appropriate method on the visitor class. In the table, each pastry class is a row, but if you look at the methods for the single visitor, they form a column. Okay. We added one accept method to each one, blah blah blah. Okay, that makes sense. Okay, visitors for expressions. Okay, let's weave into our expression class. We will also refine the pattern for a little. In the pastry example, the visit and accept methods don't return anything. In practice, the visitors often want to be defined operations that produce values. But what return type should accept have? We can't assume every visitor class wants to produce the same type, so we'll use generics to let each implementation fill in it. First, we define a visitor interface. Again, we nest it inside of the base class, so blah blah blah. Okay, so I need to use draw.io because it's later. What the hell is this? It's because it's late. I need to. Oh, that's my schoolwork. Hold on. Okay, sorry. Oh no, why is it so ugly? No, why is it updated here? Ah! That sucks. Oh, I can disable it for the app. Nice, okay. So let's say we have this object here, which can be our visitor interface, pretty much. And then we have this object. Which is our base class. And then we have our subclasses. That's the best way for me to name it for now. But inside of that we have out a visitor interface embedded. And then we can call that the polymorphism, as they call it. My brain's working a little bit slow, especially now. Kind of late. So okay, we just have to embed it. So just a bit of polymorphism, but got inherited. So I'm just refreshing my mind on that because this has been a while. Okay, that should be fairly simple. So inside of our base class, which is generate AST and define AST here. So we write class, which is our base class. I'm just gonna tag this as abstract class base name. just because that'll be easier to remember. So it's after we write why do I write a new line? I'll write a new line here, because so define visitor, which take our right. Oh, we don't have a right, we don't pass our right, we pass our file, don't we? Standard OF stream reference. We'll do that now. So we've got a file, and then we need a base name. So it'll be our base name and our types, which we will have. Right, so up here. I don't really know what I have static here. Like, I know it doesn't really change anything because it's all going to be used inside this file. I just don't really need it. So file standard string file standard string, and this could be constant because I know we're not going to change it. And our types, standard array standard string 4. Why am I using a standard array? Hello? Oh, it's because I made a standard array here. Yeah, but then I have to update it like a billion times. That's so stupid. Sorry, it's because I know that this is definitely not gonna we're definitely going to be changing that up, so I think it's easier if we just have it as that, as a standard vector. Okay, well, define visitor. So my visitor has been error because apparently that doesn't exist. Is it because our base name is not a constant? It's not a constant reference on it. Yo. You ever seen a man's brain blow up like this? But my question is, that's why. Much better. So, instead of a defined visitor, we're going to do I'm going to write into a file, and I'm going to write. Sorry, my language is flipped. Oh, okay. So this is where we use generic types for our visitor. So, let me just open up this. So here, let's say writing interface visitor with a type. This is so far what I'm getting out of this. Obviously this is going to be the Java code, and then we'll loop over our type. Over our types, where then we get our visit type name, type base, type, and then base. So it's a generic function. It'll give out this kind of name where it takes the base name. So our type will be our type, and it'll use our base name. And okay, so this is pretty much what we're trying to generate, but we're trying to generate a C++ version of it. So let me just press a little note saying this is the. Why is it? No. Okay, I have no idea why it's done that. I didn't even know VS Code does that. Like automatically does changes the type. Can I change the type of this? Sorry, this is really baffling. I've never seen this before. I thought we'd just open up a basic file. Alright, well, guess it's in TypeScript now. So in C++, we can't. There's no interface keyword, so I'm guessing we just have to use an abstract class. So there's a templated class. It was better, class or actually type there. Is type name? I think it's type name. I don't think type name and class really matter, but what's like a preference? Because I see mix and match of them. I don't really know. Anyways, who really cares, right? So, then we need to make a class with visitor where we'll have our visit type base type and base name. Isn't it like this to make it into a thing like a virtual function or something? What do you put virtual here? I think it's like that. I'm pretty sure. Let's see if there's anyone in chat. There's no one in chat. Away. Okay, well, then this is where we use a friendly ChatGPT. Actually, do I use ChatGPT or do I learn the old school? I mean, it doesn't really matter, does it? Ah. Okay, so let's see what's equivalent would be type. See, here's his type name here. It's like, should I be using class or should I be using type name? Got this. I forgot about my public thing. Virtual R base type. Okay, I was close. You would use a reference for 0, but then also a virtual constructor. Okay. Oh, deconstructor. Okay. So let's see. The method becomes passing the reference is the idiomatic way. Makes pure virtual functions of visitors an abstract base class. Ensures proper cleanup when deleting derived visitors through a base pointer. Ensures proper cleanup when deleting derived visitors. Hold on. Too late for this shit. Let me see if I explain this easier. If you delete the derived class, so reporting to the base class like this. Make sure that also runs. Otherwise, only the base part will be destroyed and any resources in my visitor wouldn't get cleaned up. Make sure when I delete visitor, the correct destructor from derived class. This is really bad, but I forgot what this means. dog is a derived class. Okay, or a child class. Child class to me just makes way more sense. So if you delete a child class to a pointer to the base class like this, otherwise, yeah, because that that makes sense. If I delete v, then the base constructor must be virtual. Okay. So make sure when I delete a visitor pointer, the correct destructor from the child class runs to. Okay. So this is what I'm trying to recreate, pretty much. So this is gonna be great. I can hard code this. I can hard code this. And yes, I do like to separate everything out, line by line like this. I think this just makes a little bit more sense. To me at least it does. So. Okay, here's where it's going to get a little bit more tricky. No. So we know that. Well, let's actually loop over our types. Can I do this? How do I loop over them here? Standard type. Types. So loop over that. There we have a standard type name, which will be our use a split function created. We'll split. We'll split our type on this, and we'll grab the first one. Dot trim. And I trim this. Luckily, I've already got that function. I forgot about that. So hopefully that will do the right thing. So this now should give us a type name. And then we'll write into our file virtual r visit. Okay, this is where I'm actually going to use stamp format. Let's make my life way easier. Okay, that's name. Type name, base name, type name, and then base name got 2. There is no lower function, so I'm just gonna ask this. Because I'm pretty sure standard transform. Maybe a simple loop. Okay, so create another helper function. Great. we have a result. Why am I copying? What am I doing? It's always copy, paste, and then analyze. So we get so we have a result variable, then dot reserve our input size. So does that mean we set the input size of our result variable to the actual input size? I'm guessing that's for some memory bullshit, right? Then for unsage.rc. Holy God. That's just pretty cool how you can run all that here. So pretty much we loop over every character in our input, and we also run this operation. We run a views transform, which is just a basic lambda function, which very much returns it does take a char. I was about to say, I was like, can't I just run this function on the string? That's silly me. I mean, there could be another function actually that we're missing. I mean, oh god, I'm gonna have to read this. Standard converts a character in character, yeah. Okay, so yeah, it's for characters, so I need to do this. Thank God for C++ way transform and views and ranges. Oh, amen. And then yeah, we just push that result back into it. Alright, let's just do that. That's banging. So where were we? So we need to get our base name. Ooh, where actually were we? Jesus, so much going on here. Just close the stuff I don't need. Hold on. Okay, so just like that. Yeah, that's pretty much everything, isn't it? So that should write what we want to the file. Yeah, and then we can write our deconstructor. So, oh, I actually didn't add a new line character here. That's gonna end up shooting me back in the face. So, virtual deconstruct visitor equals default. Oh, I don't think that's gonna shoot me in the foot. Wouldn't really shoot me in the foot, but is that. And is also a reference right here. Cool. Just like that. Alright. And I think that should actually be I think that should be everything for that function. Hold on, I'm just doing something on my second thing. Okay. Alright. I think that should be everything. Alright, anyways, where we define visitor. I think that should create this from our strings. Alright. Here we iterate through all the subclasses and declare a visit method for each one. Then we define new expression types later. This will automatically include them. Inside the base class, we can define an abstract accept method. So our base class, we're going to define AST after our define type here. We can write to our file a new line character. And then that. But the issue is, what the hell is that? What the hell is that? So where is it define AST? Where's our abstract class? Okay. So it's like as if we need to embed it Anyway, I'm pretty sure, did it go over it here? Yes, it did, look. It's at the top of the base class. This really isn't the top of the base class, is it then? I'm pretty sure those did actually give me a suggestion here. Yeah, I extend it. See, now this is where it gets a little bit confusing in my opinion, because like, I don't understand this. I'm interested. Okay, so oh my god. Oh, this is actually like a mind buzzer. So this is supposed to be our abstract class, which means that this is like a, this should also be like a virtual thing. Oh my god. Shit me, so hold on, because we've got abstract class base one. This is what I'm getting so far. That we have this, then I have this running down here, and I have something here. I'm pretty sure. So, okay, so let's say I run these past this. So define type, because this runs in a loop here. So we get class I should have just gone along with a define type. There you go. Let's just do this. Okay, so we do the Java equivalent. So we have a static class name. Maybe like type name extends base name. Where I then have my type name, my field list, and a function. Oh, because it's a constructor. I need this dot this dot field equals field, which means if I have like a field here, it'll be like that, and then down here I have a final field. Okay, I think that's what I'm getting at so far. I'm pretty sure. Let me just so, just an example. So this is like our input. Just yank this over here so I've got that template. Okay, it doesn't like that, does it? So if I run through this whole process, types gets put into define AST as expert. I'm guessing that's our base class. Define AST, you've got base name. So our base name is expert. Then we'll run through this. You've got all of this: base name, base name, base name. We define our visitor with our base name. So our base name is going to be expert. And types would be our types. Now what's our types? This string is our types. So let's take this type for example. So we'll go into our define visitor, which for some reason has an error. So we're going to define visitor. We'll create this. Might just go over here, it'll be easier. Hold on. So interface, let me split on the thing and get the first thing, which is going to be our type name. So our type name will go here. So that's going to be binary. Expert, because our base name. Type name, binary, expert. I'm doing this right? That should be binary. That doesn't make sense to my head. For me in my head, like. So it's type of binary. Okay, let's just go with it. Hold on, I'll probably understand in a sec. And then that at the bottom, I write accept visitor. Okay, that's just connecting our visitor. and then I need to go into my types because that's one thing I haven't done yet, and also this class. That's a type in it. So if I go up here, I think define type. So you're undefined type after getting all this stuff. So we get static class type name, which is gonna be our binary. Extends expa binary. And what's our field? Field and fields. Fields list. Where do I run my field list? Might actually be easier if I do it here and there. So, field list is this, right? Because so it's this right there, and we split on everything here, so then it's pretty much doing this. Yeah, I meant, okay, hold on. It's pretty much doing that. And then this dot left, left, with operator, and then where's that shift V? Down, down, down. Down. Okay. Left. Operator. Right. Should they have types? So they should. Expa left. Take operator. Expression, right? So that should be what we're supposed to be left with, pretty much. That's what we're supposed to be left with. Is there anything else that we need to be left with? I think that should be it, to be honest. So it's just transforming that into it's just transforming that into this. I mean, that into C++. But now I'm reading this override stuff here, so that means that it's an override inside of a defined type. Somewhere else here, I'm pretty sure. We write in at over. It's actually capital R. I mean O. Override. Return visitor dot visit, and we visit binary expa. Yes. I think that's what we're supposed to be left with, right? Alright. Let's just... Is this valid job? Because that's embarrassing if it's wrong. Almost, but not quite. Very close to using classic. Oh yeah, because it's too lowercase. But everything, we got everything right. It's just transforming that into a C++ code, which is a nightmare, really. And I feel like I have to rewrite it all because I'm I don't know where we are at. So after we starting to find our types. No. Oh, really? Great. I picked C++ to do this project. Then yeah, this is what I'm gonna have to deal with. Oh my god. Alright, back to the drawing board. I'm gonna see about this one. Alright, AC printer could we don't need it here. So we got a couple of things right. How is this supposed to teach me about compilers? I mean, like, interpreters, when I'm literally just... Alright, whatever. So it's telling me I need to write this, so I need to write a virtual... I need to write that, so... If I visit a bit, just outside of that. So our visitor interface, which will be the first thing that goes. And then this is all correct. This is all correct. Then we'll make a second class for Expa. So we write this class, and we need to give it this. So this is where this line would come in. This is also where I'd probably put public there, and then I would do actually two-factor hard code. No, because base class. So virtual is actually one of these equals default, where I pass our base name. New line there. We use standard NA instead of types. Okay. Interesting. I mean, it's just an extra hassle, but I do understand that. You can't extend like, oh yeah, 10 templates and everything would be like an absolute ass. I'm pretty sure I could just write speed or strength to be honest. Let's just get any except any type reference visitor 0, so it's abstract. Be our class done. So that's our class done. Then it's creating this. So then we'll go to define type, where we extend our base name, which is correct. Then, what the hell is this? Is this a constructor? This is a constructor. So, one final thing I need to write to it is just public. Just like that. And we should all be happy. And then let's see. After that, all of this. Wow. Standard unique pointer, standard unique pointer. I think this is where I just need to like define the type a bit better, to be honest. I think like this is where I would change to equivalent. How do you equivalent? Like that. Equivalent. Don't judge my poor spelling. So we'll change it to this. Okay, so that's gonna then I need to do this, which it's gonna make me cry. Wait, but I'm pretty sure, can we just not stand and move everything? Can we not just stand and move everything? Because a unique point is only one thing to point to it, so I need to move it and then move semantic, don't I? So this needs to go bye-bye. Sure. So this dot name and the name. So this would literally be, but we don't want that, do we? No. Oh my god, okay. I am having an absolute stink right now. So, at this point, we're in our constructor. We've added everything to our constructor, so we're here. No, we're not. Now we're here. So here I'll just tab it twice. Because this is C++, so realistically we are going to not have anything in here. It'll literally just be all inside of the kernel bit. There's a specific name for it, but I actually don't know what the name for it is. Anyways, we'll tab over twice, and then we're left with this. So we need a name. which would be that. Left. Let's say we're left, so we're gonna get left. Brackets. Standard move. That. So then this is the I need to add a comma after each one, right? So if I need to add a comma after each one, I'm pretty sure if I put a comma on the final one, that's a no-no. I can actually run ternary condition on that, can't I? Wait, no, because split returns a vector of all of our actually we don't really give a shit about that, do we? Fields is what we want, don't we? Yeah, fields, because you split that out of the thing. So this vector also has the property to know how many actual elements there are, so we can check if we need to add a colon or not, comma or not. Pretty much if we're at the final one, we don't need to add a comma after. Would that be fine though? That's the thing, I don't actually know if that would be fine in C++. Hold on, let me just quickly write this. And then let me just write a bit of just basic class here, just so I can test this. Text. So public. Gee, time to go to bed. What is that? Because we don't have a string color. Okay, so bear with me. Oh my god, it doesn't work. Okay, so we need to actually, we will need to do the like comma trick then. We could just do that, and then we can run a condition on that, right? Do I call it a lambda? Okay, I just do a ternary. I think I just do a ternary operator, can't I? I think I just did a ternary operation. So, oh, but we're looping. We're in a loop. So if we're in a loop, obviously we're going to need to keep track of which index we're on. Yeah, so in that case we're going to need to, we're definitely going to need to change up the for loop from one of these. For God's sake. Wait, unless I could like, can I get like the index here? No. Let me just ask ChatGPT if you like. Can I also get the index from this kind of not officially, manually go over the index, be structured binding with iterators, use this 9% clean, efficient, and see what's compatible. Okay, we'll just use this. So size ti equals 0. I'm pretty sure, isn't it? Standard size ti? Actually, no idea. Alright, so size ti Take it to 0. It's actually that. What that is. I thought it was just dynamic, like it changes depending on like however many bits your computer has or something like that. Yeah, let's just use it for now. It's right there. So this now gives us the final one, the final thing. So we'll check if I is less than fields dot is it size, isn't it? It's fields dot size. Yeah, fields dot size. If that's true, so wait, so it's less than. Yeah, so we'll return a comma with a space. Else we'll return a space like this. That should, in theory, work for our comma situation. I hope so. So then this can go away, and we're left with this beauty. Yeah, people are joining the stream and it's just ChatGPT on the left. Oh my god, that's on me. But hear me out. We're all learning here, alright? I've got to translate Java code into C++ code. Like, it ain't that easy. Maybe it is easy for some people, but I don't know. We peaked at the most views actually so far ever on a stream, so that's pretty good. Hopefully that means we're getting recommended to the algorithm or whatever the hell. But yeah, anyways, I think that should be that. So this is all the constructor. Okay, so then that's that done. And fields, we just wait, what? What is this? I wrote that. Okay, so we need to write this as well actually, but this happens only once because one except, so it'll actually be here. So can I just write this as a static string? Yeah, because I don't think we're using any. Actually, yeah, look, we're doing this. Yeah, look. This is the binary visitor. Is that because I expressed over here? Yeah, this. Okay, so that's another thing that I need to worry about. That's part of override, except so. That's the mix. Okay, yes, we can easily sort that out. So standard any except get our visitor. Standard any reference visitor. Override, because we're overriding this function. Oh, someone said fireworks outside. It's not even Halloween yet. What you doing? It's actually quite being clear outside actually then. Maybe I should go get some fireworks. Okay, anyways, we're returning our visitor. Okay, this actually I'm gonna need to do a standard format. Standard visitor, return visitor dot visit. And we'll pass in a pointer to this, like that, and we get our last name and our base name. Nice. And then we need to finish it off with one of these. Then here, failed. Final field. Noise that. Noise that. Noise that. Noise that. Noise that. I think it should be fine, right? You only just adds final here, so that's final there. But surely that doesn't really matter, does it? Because we're in C++, boys. We're in C++. So that should be it. Actually, I think that should be it. Then I need to do this, which is an absolute headache. But hopefully this works. Anyways, we need to change this. So this will now become standard unique pointer expert, and then that also means at the top of this file define our imports. So our imports, I'm pretty sure actually we had it over here next to Mr. GPT right here. So I need to write the imports. New line, paste. We'll include memory, we'll include any, and we'll include IO string. Not. Oh yeah, it's always nice to have IO string, right? Oh, I can do this. Also, look, ChatGPT gave me this, the AST printer, which is what we go on to next here. Do you give me a visit primary expert? Is it grouping expert? So, create a new file for this, but here it's telling me like, kind of telling me to do it here. So, the AST printer. I don't think I need to actually. I don't think I need to. Right with that. Also, another thing. Does this override? Well, I never really thought about this, but. Does the way I open the file now override every time it opens? Because we don't want it to override every time it opens. I don't think. It never said anything in there about overwriting or appending, but I'm guessing if we're going to reuse this is a very reusable thing, or I could have just hard coded all this C++ like that. Like, it's literally right here. But, oh, actually, I don't think I've done this yet, so I'll have to do my 4 declarations. But, think about it. We're trying to reuse this, which means we're gonna need to. Oh, we're gonna want to reuse it. So we shouldn't override the file every because we want to append stuff to it. My favorite friend right here. Will this override? To append instead of so I have to give it some properties and the arguments. Standard iOS I hope that allows it. Yeah, no, that's exactly what I wanted to do. So we append the right, open to the file. We obviously have to find visitor here, but I also need to do it for declarations, so define visitor, base name, types. Alright, we'll have to do it like this. Define for declarations. So auto define forward decal. Don't spell declarations. We're probably going to need the file. So standard OF string reference file, standard string. Yeah, we actually will need the base. And actually, I'm pretty sure we can just copy this here. Okay. Forget I even tried that because obviously that's not going to work. So with that, we'll I'll just write the base name. I don't even need to run SCD format every single time. I could literally class base name. There we go. Just because I use standard format for everything, as you can see here, stuff because I like it. Because like, as someone that comes from like F strings and Python, actually I don't come from F strings in Python, but I love F strings in Python. I feel like it's kind of stupid that that doesn't exist in C++. Dude, I think a lot of stuff is stupid that doesn't exist in C++, but what you're gonna do, right? What you can do is just mope about it. And now I've lost where I was here. Okay, so we'll always have a base name, but then I need our types. So we'll loop over our types, we'll trim that, because pretty much what we're doing here is kind of similar. We have a type name, and our type name goes before our expa. So it's our type name. So we just need our type name. So file class type name. Sorry. New line, and that's it. And then we'll just write another new line character right there. And I'm pretty sure that should be good to go. So then we can do define forward decal file, our base name, and our types. Ooh, Ella Butterfell, which is then, actually we don't need that yet. So, wow. Okay. That gives our 4 decorations. We have decorations, our visitor, our base abstract class, base abstract class, and then our type classes, which are going to be any of these. I think so. And then we also have a printer which we could implement. 5.4. But I don't know. I'm kind of scared. But I feel like we should run this. I'm not gonna lie. We'll run it with G++, because why not? G++ run generate ast.cpp dash o generate ast dash standard C++ 20. I think you define this here, don't you? Okay, and then yeah, okay, let's just give it a run. I hope we can leave it on a good note. CD tools. She compiles. I need to pass it a path. Should do a new file here and be like, output directory. Let's do. I don't know, AST stuff. Let's do AST.cp. I hope it takes off of this direction I'm currently at, so AST.cp. What the hell was that? It opens something up. Pick an application to open the C++ file. Oh wait, is it because I'm doing this? Nice, okay, so that's great. There you go. Oh, I accidentally tabbed back into the other one. I was gassed. I don't know. It's not writing to the file. It's not writing to the file. I'm so confused. I'm actually so confused. So look, I'm supposed to, so the path is the output directory, which is what we get from our thing, our GGV. Basing.cpp. me just copy this. Easy way on. Why doesn't this create a Oh my god. You can't create. It doesn't create directories. Of course it doesn't do it. Of course you can't create directories. Luckily that isn't that bad. But that's interesting. I didn't know that. I thought it could literally just easy swear. Rayham Camille. I hope I said that right. Thank you so much. Thank you so much. And we're following along with crafting interpreters. If you've ever heard of them, they are. I mean, to be fair, so far so good. It's written in Java though, so everything I'm doing right now is I'm translating Java code into C++ code, which not the best. But no, thank you very much for the support. It's going well. Oh, in my opinion, I think it's going pretty well. But we're learning something new every day because I'm learning. So hate on me as much as you want for using ChatGPT, but this tool is amazing, and it's we're still learning, and that's the whole journey. Even if it looks like I'm like you're copying, like who really cares? Ensure directory exists. And then well, this works, and then obviously I have to can I just I'm not sure you throw a runtime error. No, let's just copy this code. Just open up that file. Actually we don't even need these parentheses. Cleans up the code a little bit more. Alright. Should be good to go. Ensure file exists. Pretty much. Oh, ensure file works. And there's this compile it again. So now we can run it with okay, this time it did not create a directory. It actually makes me think that I don't even run this function. Unless I need to reload. No. No. No, you don't. As if you can at least like let's at least see out something. Okay, I mean, if you think so. Which keyboard do you using? I hope actually, I didn't actually think about that. Is it too loud? You gotta let me know if it's too loud. I'm so sorry. I actually completely forgot about that. Oh, I slipped my mind. I'm using the Aula F75. It's a new keyboard I got. It's got like this. I don't know which switches they are. It's just the ones I picked up on Amazon. But yeah, I completely forgot about keyboard clack. I hope it actually isn't that bad. Because if it's really bad, then I'm sorry. Then you got to listen to that clackiness. But yeah, it's the Owlet F75. Should I type in chat as well? Hold on. F75. Smiley face, there you go. Yeah. Wait. Oh my god. Oh, you know it's late. You know it's late when you're trying to run the .cpp file so the .exe file. Oh my god. Oh, you know it's late. You know it's late. Yeah, no, it's a good keyboard. I really like it. I think it's really comfortable as well. And it's really creamy. Oh, out of context. Blur that out. But no, it's a good sounding keyboard. Trust me. Maybe. I don't know, there's nothing else for me to say. Anyways, hopefully, now I can do this. And it'll create it with the file and everything. Thank God. Oh, I was actually bugging out for too long. It works. It does. It works. It works. It works. It works. The only problem is it's going to give me a billion errors because I didn't do this. But it works. That's the most important thing. Alright, hold on. Let me quickly change this to this where it works. It needs to be OP. Token. Token. It told me to do it like this, but I don't know if I'm going to be having like a token class. I'm pretty sure it's going to be a token class that I might have. I'm pretty sure. For now I'm going to leave it like this. Token class? Question mark. Let's quickly modify all these to be unique pointers. Object value. See now, isn't a Java object literally like a null, but like, isn't it just like nothing, or like a template kind of thing? It's like a any. Because then doesn't that just become standard any? I'm actually not sure. I need to actually have a look at that. Right. So you seriously, you're gonna... Oh my god. I'm pretty sure all of these have to have a space in them. Whatever. Okay, so object. Object in Java. No, not JavaScript. In Java. Java class and objects. Yeah, no, this is classes. I want the object keyword. Maybe if I put capital O, like it more? No. Okay. Let's type in object type in Java. In Java, the root class for all classes, yeah, would have thought so. So it pretty much just means that it's like the best. It's like an interface. It's the best interface. You can get any kind of void pointer or standard NA. Yes. Ooh, yes, please. Standard NA. See, the only problem with that, right, is the Anycast. Like, I'm not too keen about that. I had a bit of an issue with it last time. A value, use standard NA to store any kind of value, but then when it comes to accessing that value, you need to cast it to the actual type. But that point of using standard NA is to, like, you know, to store any type, but you're not sure what type it's going to be. I'm pretty sure then you run like a conditional thing to make sure that it actually works. But I feel like casting such a thing is like a bit weird. I feel like it should be implicitly done. I mean, when you have other programming languages, you can pretty much just get the dot type from it, I'm pretty sure. Hola, ¿cómo estás? That's Spanish, isn't it? Hold on. Muy bien. I don't know, I took Spanish in secondary. I said I took Spanish, I have to do Spanish in secondary, and I got pantalones and ¿cómo estás? But pantalones. Okay, so that should be standard, I'm guessing now. Okay. Anyways, I'm pretty sure that if hopefully now I compile that and run it, we should get a semi-decent outcome. Oh my god. We did not get a semi-decent outcome. I see 9+ errors in the top. You know what? It could be worse, you know? It actually could be way worse. Sorry, I don't speak Spanish. If you don't speak Spanish, how did you say, then how come you say hola, ¿cómo estás? Because isn't that Spanish? You know, just something to think about. She doesn't like that because there's no brackets. Oh my god. Jeez, this has been going on for 100 minutes almost. We're at 99 minutes on the stream. I think that it is about time maybe to go off. I mean, look at the clock. Just like look at the clock down there. I don't really know if you can really see that because there's no clock, so it was down there. But it is 4 minutes past midnight, which is bad. Which means that I think it's about time where we can actually get off and actually give the brain rest. What stage are you at in your project? To be honest, it is still fairly at the beginning. I mean, creating an interpreter, which is pretty much what we're trying to do now, is a struggle. And I know it's a long process, 'cause I've tried it before, and we're at the beginning still. It's just, I'm following along with this ebook, pretty much. It's kind of like an ebook, but we've been going at it for a little bit now. Oh yeah, the point I'm trying to make, the ebook is in a completely different language, so I have to translate it to C++, which is the language I'm using, which is just a bit of an extra struggle really, because C++ is a bit of a head knock, if that's the best way to call it. So we're at the beginning still, we're getting stuck, but we're learning a lot, which is the most important thing we're supposed to be learning. So yeah, I mean, we're close with this. We're close with this, with what we're trying to do now, with this stage. But it might take a little longer. So I think I might have to finish off next stream. But yeah, around the beginning of the project. Yeah. Got a long way to go, and we've got plenty of extra streams. Cause I'm trying to stream as much of it as I can, because when I stream it, even if it's to like nobody, I still like kind of encourage myself to keep pushing through it. Like, I did not want to do this today, but I was like, you know, if I put myself on a stream, I'll force myself to do it, and we did. Great. Do you do it for learning purposes? Yes, I am doing it to learn, but hopefully something good comes out of it. I mean, to be fair, a big project like this is always good to just show off in general, like CVs, you know, for employers. So if I could tell them, hey, I created an interpreter in one of the hardest languages, then it's like, it's pretty cool. And yeah, but no, at the moment it's mainly for learning purposes, because I'm trying to learn CPP for myself. It's going alright. I've read what was it? Like a walkthrough of C++20, like modern C++ by Bjarne Stroustrup. I'm not sure which book it is on it. This one, a Torah C++, but the newer version. This one's the old one. So yeah, a Torah C++ 20. And I was like, you know what, might as well give it a try. I mean, it's not, I don't know how much of it in demand it is, but I know it's one of those languages that when you know it, you'll know it. When you know it, you know it. And because it's so complex, I feel like you understand a lot about how programming then works and all the low-level features of programming. Obviously this isn't something like assembly. Oh, that voice crack. It isn't as bad as something like assembly, but it definitely teaches you quite a lot of concepts that something like a very common programming language would not teach you, like Python or something. But yeah, no, it is pretty cool. Thank you. At least we got some support. At least you got some support on the project. I love low level. Nice. Do you do anything to do with programming or anything like that? I mean, your name's Tech Coffee. I mean, I'm just trying to link some dots. I'm guessing you're into some sort of tech. I took the Nerd course on the course. NAND2 Tetris. NAND2 Tetris. What am I looking at here? Materials aimed at students such like this. I mean, I'm guessing it's to do with low level, like how electricity. Is it electricity? I'm not sure. Is it electricity? Because I know it's to do with like how chips work. Because I have dabbled in low level stuff like microcontrollers and stuff, but never too much into it. And 2 Tetris. That's actually really cool. I've never heard of this before. I finished the part 1. What, Boolean logic? That's what I just clicked on. Oh, it's all PDF. Oh, it's a long PDF. Oh my god. Oh, these are like full-on lectures. Oh, fair enough then. Fair enough if you've done that. I hate reading. Yeah, so yeah, like electricity flow and stuff like that. Nice. No, that's really cool. This is really cool. I just want to understand a little bit how the hardware works. Yeah, of course. No, I mean, it's always good to know, like, how it really works under the hood as well, because a lot of the time, there's a course on Coursera. Yeah, what was I talking about? Oh yeah, it's good to know how something works. I mean, I've always liked that. Where, is it any one of these? I mean, what have we got here? We've got build a modern computer from first principles. Oh, so is that what Nanta? So is it like? Do you learn how to create a computer then? I'm guessing you create Tetris out of it. I mean, that would make a lot of sense, but yes, nice. That's really cool. That's actually really cool. I might actually have a look at that, to be honest. That's actually really cool. I'm going to save that into my bookmarks. That's always something like that I've also been partially interested in, but never really got around to doing it because I've always just done programming stuff. On hold computer. Do you mean on old computer? Sorry, I'm just I'm just trying to understand that unless I'm being a little bit stupid. Just a CPU, you can plug RAM and ROM. Oh, nice. So just a very bare bones computer then. Bro, I am going to. What are you gonna do? What are you going to? Gaming R-knob. What are you going to? Wait, so just final clarification, we've got you're trying to build Tetris from just a CPU where you can just plug RAM into it. Oh, RAM and ROM. Just to for clarification is what I mean. So you're trying to build Tetris on just a CPU, RAM, and ROM. Is that what I'm getting? And don't worry, it's all good. All good in the hood. There are two parts of the course. One part where we build the hardware and another where we do the software part. Oh. So that's proper low level. So you're fully building a little computer and Tetris on top of that. That's really cool. That's nice. But I'm going to start programming, but I prefer decide what's language well for beginners. What programming language prefer? Programming language. I mean, you eventually get to the point where it's like you learn so many programming languages that each one is better for a different job. But I would say if you're starting to do programming, I would look into probably Python as the programming language, or JavaScript. It depends which way you want to go. If you want to do like more general programming stuff, go maybe Python. It's quite easy. You get building very quickly. Or you could go into JavaScript, which is also still fairly easy, but a little bit more complex than Python. But it's also more into web development, because the whole web, like the internet, it kind of works off of JavaScript in a way. So it depends what you want to do. If you want to do like website stuff, obviously it's nothing wrong to do a lot of different things, trying stuff out. But if you want to start off with websites, I would look at JavaScript with HTML and CSS. Or if you just want to go into like some general basic stuff, I would look into Python. I do not speak Spanish. Oh, let me put that to Google Translate a sec. If you don't mind tech coffee, give me a second. I do not care. There is a simulator that the course provides with a screen. Oh, that's cool. That's really cool. No, that's good. That's how a lot of courses are nowadays. I feel like they have. I'm pretty sure it's called a sandbox, or is that for like hacking stuff? I don't know. I did some in college about it, but yeah, no, that's good. That's really good, because then you don't always have to buy the hardware. But Java. What do you think? Java. Yeah, Java's good. I mean, it's gotten better now. There's like is it Java 25 came out? I think Java 25 it looks good, and I want to try it, but I don't want to learn another programming language. But I have tried like old Java, like Java 8. Is it Java 8? I think it's Java 8. But yeah, no, Java's good. It's a bit more complex. If you're new to programming, I think message retracted. Oh, okay. I mean, if message retracted, then I'll just stop talking about him. There is a simulator that is provided. The simulator has a screen, and the pixels of the screen can be manipulated by changing the values of the RAM of the computer. Whoa. That's good. That's very good. Yeah, I mean, I'll definitely have a look in my spare time at that, because that's really interesting. I like that. And you don't even have to build it physically, I guess, because if it's all a simulator, then you learn everything you need to learn without spending the extra money, and I think that's really good. Yeah. But Arnob, if you like I said, with the programming language, that's what I would recommend. I've seen a little message around about Java. I mean, go ahead. You can dive deep, or you can dive slowly, I guess. It's all up to you, man. It's all up to you, my man. For Java, I can really only see it for like if you want to make something, like if you want to make back-end services with like Spring Boot or Minecraft hacks. That's all I can imagine. That's all I can imagine using Java for. Just either Spring Boot or making Minecraft hacks. Or mods, actually. Mods is probably the better thing to say in this situation than hacks. Don't promote cheating. Yeah, Tech Coffee. Man, keep at it. I mean, you'll probably learn a lot. It seems like a really good course, and it's quite a deep dive. So yeah, keep going at it, man. Because it's good to hear people doing that kind of stuff, because you don't really hear nowadays a lot of people talking about like low level stuff. But that's really cool. Anyways, it is now 20 past midnight, and I think it's time to call this project a pause. Yeah, I need to I think for the next time we need to review this code and then update this so it works with this. Oh, creates the right thing. And yeah, so thank you everyone for coming, watching, and I think it's the end. We can maybe stream tomorrow. What time? Unsure. Subscribe and turn on notifications. That's what they all say. So then you'll know. But yeah, we will probably be live tomorrow. So yeah, thank you everyone for joining in, and take coffee. Keep at it, bro. Keep at the course, because that course is really good. And come back to my stream. I want to know how it goes, because I'm curious. I want to know how it goes. And yeah, see you guys later.